Hello and welcome to this demo. In this demo, we're going to look at deploying our application on Google Container Engine or Kubernetes Engine on Google Cloud Platform. We will first start with setting up our Google Container Engine platform, and then we will proceed with creating the service definition files for pods and services. And then we will proceed with creating the pods themselves on Kubernetes and creating the services, and we will try and access our application that's hosted on the Kubernetes cluster. So let's get started. Okay, so here I have my Google Cloud console. I'm logged into my Google Cloud platform with a test account, and this is my dashboard. We will now look at what Kubernetes Engine is. So if you look at the documentation page for Kubernetes Engine, you can see that it's a managed environment for deploying containerized applications on Google Cloud Platform. You can see its various features on this page. And so this is basically a pre-configured Kubernetes cluster that you can get on Google Cloud Platform with a single click. If you scroll down to the bottom, you will see a link to a quick start, and if you go in here, you will see basic information on how to get started with Kubernetes on Google Cloud Platform. So we're going to follow these instructions. So I'm logged into my Google Cloud Platform console, and when I go into the menu on the left, I have Kubernetes Engine on the left, so I'm going to click on that. And this takes me to the Kubernetes dashboard. So I do not have any cluster for now, so I'm going to click on Create a Cluster. And this brings up the form to create a cluster. So I'm going to give a name, example voting app. Just going to add a description. It is a Kubernetes cluster to deploy our example voting application. I will leave everything else as at the default, and I'm going to click on Create. So what this does is it basically creates a Kubernetes master node and 3 worker nodes, and take me to, and that's going to take a few minutes to deploy. And once it's ready, I will see a green check mark. Now, I just clicked on the Google Cloud Shell in the top right corner. What this is this gives me a temporary shell that I can work with. So it is in this shell that I'll be running all my Kubernetes commands. Now it takes a few minutes for the cluster to be set up. So what I'm going to do for now is I'm going to click on the connect button on the example voting app cluster, and it gives me instructions on how to connect to my Kubernetes cluster. So in my Google Cloud shell, I could run this command which is gcloud container clusters get credentials. I could run the command to get the credentials to connect to my Kubernetes cluster, and then once that command runs successfully, I will then be able to use the kubectl command line to interact with my Kubernetes cluster. So I'm going to copy the command, and I will run it. I'm not sure if it's going to work because the cluster has not fully been set up yet. And yes, as you can see, it gives me a warning that states the cluster is still not running. So I'm going to wait for the cluster to start up. And yes, as you can see, I now have a green check mark next to the example voting app. And that indicates that the cluster is fully set up. So I'm going to rerun the command again. And as you can see, it says the kubeconfig is configured correctly. I should now be able to run kubectl commands on my Kubernetes cluster from this terminal. I'm going to run the kubectl get nodes command to get a list of nodes available in my cluster. As you can see, there are 3 nodes available and they're all in ready state. And I could run the kubectl get pods command to see a list of pods. And since I haven't created any pods, I do not see any. And I could run the kubectl get services command to get a list of services. But as you can see, there's one service already created, and that's a default service created by Kubernetes. So we can leave that at that. So I now have my Kubernetes cluster ready on a Google Cloud Platform. I'm now going to create all the definition files for pods and services so that I can then use those files to create the pods and services I need on the Kubernetes cluster. So I have opened an IDE on my laptop, and I've created a folder called example voting app kube. And in this folder, I'm going to create the different files needed. So first, I'm going to start with a pod definition file for my voting app. So I'm going to call it voting app pod.yaml. Okay, now in this file, I'm going to define my YAML definition. I'm going to start with version as we discussed in the lecture. So I have API version, kind, metadata, and spec. So always remember these are the 4 major sections. So I will always start by just putting all the 4 there, and then I will go ahead and start filling in values for each of these sections. So I have all the 4 defined. Now I'm going to specify the version, and that's going to be v1. I then have the kind, which is pod, because I'm now creating pods. And under metadata, I'll always start with name. So the name is going to be voting app pod. So that's the name of my pod. And then I always have labels. As you can imagine, labels are used to tag the pods or resources that we create on Kubernetes. This way, you can later search these resources based on these labels. So the labels are later used with services to allow services to search and find out the respective pods. So I'm going to create a label named name. I'm going to give that a value of voting app pod. Then I'm going to add a label called app, and I'm going to call it demo voting app. So my application is demo voting app, and the name of this pod is voting app pod. I'll use the same format of labels for all my pods and services. Okay, so the next is a spec. So spec for specification. Since this is a pod, I'm going to have containers inside it. So everything that comes under spec section is dependent on the type of definition you're creating. Since this is a pod, I will have containers. If I were creating a service, then I might have ports under it. So I'll start with containers, and under containers we provide an array of containers. So I create an array with a name as voting app and the image that is used to deploy the container. What I'm going to do now is I'm going to go to Docker Hub and search for Docker samples, and that's where I can find all the images for my voting application. And there you can find the example voting app. What I need is the vote app itself. So I'm going to copy the name for the example voting app image. And that's the image that I want the pod to use. So I'm going to specify the name of the image under the image section. And then finally, I need a port to be exposed. So I'm going to add a port section, and under that I can provide a list of ports. In this case, I'm just going to have one port, and I'm going to call that, and that's going to be 80. Okay, so now I have my voting app pod definition file ready. So if you look at it, first I have the API version, which is v1, and then I have the kind set to pod. I have some basic metadata where I'm providing the name of the pod and some labels. And then I have specification under which I have containers. So since this is a pod, I have containers under specification. And we only have one container per pod, which is why I only have one image specification under containers. So the name is voting app, the image is the name of the image that I want the pod to use, and then the image exposes port 80, so I'm going to add the port 80 under the port section. Okay, now I'm going to use the same file to create other pods. So I'm just going to copy the same file and create a duplicate of that, and under that I'm going to have worker, so worker app I will now create a pod for worker. So for worker, everything remains the same. The API version is going to be v1. The kind is going to be pod. I'm going to change the name to worker. I'm also going to change the label to worker. And under specification, I'll change the name of the container to worker and the image as well. So we'll change the name to worker, and I'm going to change the name of the image. So I'll go back to the Docker Hub. I'll find the worker image, and then I'm going to copy the name of the image and place it there. Okay, so I have my worker container. Now the worker does not expose any ports because it's not a web application, so I'm just going to remove the port section for the worker. Okay, I'm going to create another copy of the voting app, and I will now create a pod for the result app. So I'm going to name it result-app-pod. Then again here everything remains the same except the name, so I'm going to change all the name to result. The name of the container also from voting to result, and then I'm going to go to Docker Hub and get the name of my result image. Okay, and I'm going to replace the name of the image with the result app image name, and the result app exposes port 80 because it's a web application, so I'm going to leave the port section as it is. Okay, so I'm done with all the 3 application pods. I have 2 pods remaining, which are for Redis and the Postgres database. So I'm going to create a new file for Redis pod. I could have just copied, but I'm just going to create a new file for the Redis pod. I will name it redis-pod.yaml, and I will copy the contents from the voting app again. And this again, it's all going to remain the same except for the names. So the name is going to be Redis. Instead of voting app, I'm going to rename that to Redis-pod. The label as well to Redis-pod. And the name of the container to Redis. And the image name is going to be Redis. The port is now going to be 6379 because that's the default port that Redis exposes. Okay, so I have my Redis pod. I'm going to create a copy of that, and I'm going to now create the Postgres database pod. And in the Postgres pod, I'm going to first rename all the names and labels to Postgres. And the name of the container will now be Postgres, and the name of the image is going to be Postgres with a tag of 9.4 because that's the version that the example voting app uses. And the container port is now going to be 5432 because that's the port that Postgres listens to by default. Okay, so I now have all my 5 pods. Now the next step is to create services so that these pods, once deployed, can communicate with each other. So first I'm going to create the internal services. So I'm going to create a new file. I will name the file redis-service.yaml. Okay, so again, in this file, I will define the base structure, which is going to be API version, kind, metadata, and spec. The API version is going to be v1. The kind in this case is going to be service. Metadata is going to have name, which is going to be Redis, and labels. Under labels, I'm going to have name, which is going to be Redis service, and the application is going to be demo voting app for all of the pods and services. The specification, so since this is a service, we're going to have ports under specification. Earlier, when we created a pod, we had containers under specification. Now we have ports. So what this says is under ports, I'm going to provide a list of ports To start with, first it's going to be 6379, and I need to give a source port and target port. So the source port is going to be 6379 and target port is going to be 6379. So what is it going to listen on? Where does it listen from? So let's say we have 5 different pods running. When we run the pods, when we create the pods, we'll have 5 different containers running. We'll have the Postgres database, Redis, the voting applications, etc. Now, when we create this service, we're basically telling the service to listen on port 6379 and forward that to port 6379. But where exactly is it listening from, and what exactly does it forward to? So we need to link this service to one of the pods that we created so that it knows to work with that particular Docker container in that pod. So how do we specify or link this service to a particular pod that we have created? For that, we use selectors. Under the specification, we create a section called selector. So under the selector section, we provide a list of filters. So what do we filter on? We filter by list of labels, and this is why we labeled each of our pods with a different name. For example, if we go back to our Redis pod, we can see that under the labels it has a name and an app. So if I copy that whole section as is and paste it under the selector section, when the service is created, so it will link the service to a pod based on the filter that we have provided here. So in this case, it is going to link this service to the Redis pod because it is the Redis pod that has the label based on these filters. Okay, so we have the Redis service. Now we're going to create another service. So I'm going to copy the Redis service and create a Postgres service. And this is for the Postgres database. This is for exposing the Postgres database to the worker and the result app. So in this Postgres service file, we're going to rename the name of the service to DB because this is the name that our application listens on. So remember that the services should be named based on what the other application is looking for. We know that the worker app tries to connect to a service on the host named DB. So this service should be named DB or whatever our applications are looking for. The label is going to be DB service. The port in this case is going to be 5432 because that's the port that the Postgres database listens on. And the selector in this case is going to be the selectors, the labels we have defined for Postgres. So I'm going to go back to the postgres-pod.yaml file and I'm going to copy the labels under the Postgres pod. I will put that labels under the selector section. So this enables the Postgres service. When it is created, it will link the Postgres service to the pod that it can retrieve based on these filters we have provided here. Okay, so the next step is to create a load balancer or external service so that our users can access our application. So what we're going to do is we're going to copy the Redis service and we're going to create a new service and we will call that the voting app service because this service is going to expose the voting app to the external world through a load balancer. So we're going to modify the name to voting service. We will change the labels to voting service. The port is going to be 80 because that's the port that the container exposes. And we will need to change the selector to link the service to the voting app by copying the labels from the voting app and putting them under the selector section. Okay, now we have our voting service ready, but like the Redis and the Postgres services, this is not an internal service. So by default, the services are created with a type called Clusterip. The services created with cluster IP type are only available within the cluster. To enable the service to be accessible outside the cluster, we must change the type of the service to something else. So in this case, we're going to change the type of service to load balancer. Okay, so we are ready with our voting app service. Similarly, another service that we want to expose outside is the result app. So we'll create a copy of the voting app service and we'll create a result app. And in the result app, we're going to rename the service from voting to result. Similarly, we're going to relabel the service from voting to result. But remember, for these services, the labels doesn't really make sense. So you really don't need to have these labels for these services because we are not querying these services from any other resource or selecting these services from any other resource. So it doesn't really matter, but it's a good practice to label the services appropriately. The type is going to be load balancer, the ports are going to be 8080, but the selector in this case is going to be the selector for the result app. So I'm going to copy the labels from the result app and I'm going to put it under the selector section for this service. Okay, so I now have the service ready for the result app. So I now have 5 pods and 4 services. Out of the 4 services, 2 of them are for Redis and Postgres database, so they are internal service, and I have 2 services for the external users, which are for the voting app and the result services. So I'm all set with my definition files, and now all I need to do is go to the Kubernetes cluster and deploy these services. Now, what I'm going to do is to, in order to copy these files over, I'm going to check in these files into my GitHub account. I have created a new repository on my GitHub account, and I've uploaded all these files into this account. So what I'm going to do is I'm now going to copy this, the link to this GitHub repository, and on my Kubernetes cluster, I'm first going to clone the repository so that I can get all the files on there. Okay, I'm now going to clone the repository using the git clone command. Okay, so that's completed. I should now have a new folder named Kubernetes example voting app. And that's there. So I'm going to go into the Kubernetes example voting app and I can see all the files that I just created. Great. So now I'm going to go ahead and create these pods and services one by one. I will start with the voting app. So what I want to do first is I just want to start simple. So I'm going to deploy the example voting app, the voting piece of it alone, and I will create the service and I will just try to access that voting app alone first, just to make sure that I'm able to deploy that and access that from a browser. So I will use the kubectl create command -f, and then what I'm going to start with is the voting app pod. Okay, so I'm going to give the name of the pod definition file, and that is going to be voting app pod. Okay, great. So I see the message that voting app pod is created, and I will just wait for it to run. So if I do a kubectl get pods command, I can see that it's running. So if you look at the ready state, it's 1/1. That means that 1 of 1 containers is running, and that's good. Next, to be able to access this voting service from a browser, I need an external service to be created so that I can access it. So I'm now going to create the service for the voting app service. So that's going to be kubectl create -f voting app service.yaml. Okay, so I've got the message that says service is created. I could now list the services using the kubectl get services command. Okay, so if you look at the output of that, it says there's a voting service that is being created and the status is pending. So it's currently deploying the load balancer. So if I go to the discovery and load balancing section in the UI, I can actually see that the voting service is in the process of creating a load balancer service. So I'll just have to wait and give it a few minutes for it to deploy the load balancer service. The load balancer service only works on public cloud platforms such as Google Cloud and AWS. So this is in fact relying on the Google Cloud's load balancer. When I click on refresh, it's refreshed the status and now it's okay. I can now see the external IP address. So if I simply take the external IP address and go to a browser, I should now be able to see my application. Or in the UI above, you have a link that will take you directly to our application. So when I click on that, I can now see the cats versus dogs interface and my voting app. The first piece of the first component of our application is up and running, and the load balancer has been configured successfully. So that's great. Next, I will proceed with the remaining components. So I will first create the Redis pod because my voting app is dependent on the Redis pod. I will use the command kubectl create-f and redispod.yaml. Okay, so the Redis pod is created. If I do a kubectl get pods command, I can see that it's already running. So that's good. And now I will create the Redis service so that my Redis pod is available to my other pods. So I will do a kubectl create-f redis-service.yaml, and that creates the Redis service. If I do a kubectl get services, I should now see a new service created, but if you look at the type, it says Clusterip, and that indicates that it's an internal service. Okay, so at this point I have the first few components deployed. I will now proceed with the Postgres database. So I will create the Postgres database pod. So I will run the kubectl create-f postgres-db-pod.yaml, and I get the message back saying the pod has been created. If I run a kubectl get pods command, I can see that it's in the process of creating the container. So that may take a few minutes depending on the size of the image, etc. But I really don't have to wait for creating the service, so I could go ahead and create the service for the Postgres database. So I'm going to do a kubectl create-f postgres-service, and this will create my Postgres service. This service will enable the other component to access my Postgres database. So if I run the kubectl get services command, I can now see that I have the DB and it's of type Clusterip. And next I will deploy the worker app. So I will run the kubectl create-f or worker pod. I will run the kubectl get pods command to see that the worker app pod creation is in progress. Now, I don't have any services for that because no other components are actually relying on the worker pod. I'm now going to create the result app pod. So I will run the kubectl create command and provide the result app pod definition file. Okay, so the result app pod definition file has been created. I will also create the result app service for making the result app available externally. So I will run the kubectl create-f result app service.yaml command. So I have all of my pods running and I have all of my services up and running. The result service is still pending as it's busy creating the load balancer. So I'm going to go into the UI and refresh. And as you can see, the load balancer service configuration for result service is in progress. So I'm going to wait for it to be available. Okay, so it's ready. And when I click on the load balancer IP, I can see that it's up and running. And if I now go and cast my vote, I can see the result being updated instantly. So this confirms that our application is working and it's all integrated with each other using services. Okay, so that's the end of the demo. We have successfully created a cluster on a Kubernetes cluster on Google Cloud Platform. We have created the files required to create pods and services. And we have hosted our application on the Kubernetes cluster on Google Cloud Platform.